Good evening. Welcome, everyone. Thanks for joining me today. So we'll be talking about TypeScript and why you should love it. So let's get on with it. About myself, I'm Deepu K Sasidharan. I'm an ardent fan and supporter of JavaScript and the ecosystem. I'm also co-lead of JavaHipster or JHipster, a very popular rapid application development platform in the Java world. I work for a company called XebiaLabs. We make DevOps products. We are based out of Netherlands and the US. So I have written a book about JHipster. If you know about it, know about JHipster, and if you're interested, please check it out. So about my company, we build release orchestration, deployment automation tools. Obligatory slide, since they pay for my trip. So what about you? How many of you are Java developers here? Okay, I see a lot of them who are not, apparently. This is a Java conference, guys. Okay, just kidding. Web developers. Almost all of them. How many of you love JavaScript? Okay, like JavaScript? TypeScript? Okay. Other technologies like Angular, all these things, React, Vue.js. Okay. Now, the most important question, how many of you attended my TypeScript deep dive session yesterday? I'm so glad. Just you. I'm so sorry for you. This is basically a short version of the same. Huh? So I hope you're aware. A lot of Java developers kind of hate front-end development. This I have seen over the years. They always cringe when it comes to front-end development. They always shrug when it comes to front-end development. They kind of treat front-end development tickets like a punishment. So it's quite normal. Some of the concerns are quite valid for some, but some are a bit far-fetched, I would say. The reason being, like, say, around 8 years ago, we had jQuery and we were very happy with it, right? So the only front-end stuff you would do is go write a, say, Ajax query, or like do a DOM manipulation with jQuery, and you'll be so proud of it. Like, hey, I did this awesome stuff with jQuery, right? Then suddenly, when you mastered jQuery, there was the rise of all these MVVM frameworks. Then suddenly there was Angular, then React, then Vue, this, that, Preact, this. So there was like one framework every week. And suddenly you were like, all your jQuery mastery were irrelevant, right? Then now you have to learn new technology like every other week. So as soon as you become good in Angular, then there is Angular 2, which is like a scam actually. It's not a new version of Angular. It's an entirely new framework, just named after the same thing, right? Then suddenly there is React, there is Vue. So you have to keep yourself updated with all these things, and it's quite daunting. And coming from the Java world, I can relate to you because I'm also basically a Java developer as well. So in the Java world, things don't quite move, don't move that fast, right? So you learn something, you become good at it, you know that's going to stay forever, right? So you don't have to worry about it becoming obsolete, right? So, and Java will survive. So there has been a lot of technologies coming and going, but Java, JavaScript, these things are going to be there forever, right? They're not going to die out. So you're quite safe there, but not so in the front-end library space especially. They come and go like flies every other week, right? And this also gives us yet another framework syndrome, right? How many of you have actually thought about this, or how many of you actually are bothered about this yet another framework syndrome in the JavaScript world? Okay, that's a good show of hands compared to last year. I think last year during another talk, I asked the same question, and there were a lot more people who were bothered. So that's a good sign. It also shows that this trend of yet another library every week is slightly slowing down as well, which is good. So how can you make Java developers hate JavaScript less, maybe, or like it more, right? So one answer that I would propose is TypeScript, which makes you feel closer to home when it comes to typing and all these things if you're coming from a Java or like a strongly typed language background, right? So let's see what TypeScript is. So it's a strict syntactical superset of JavaScript. That means anything valid in JavaScript is valid in TypeScript. So you can expect to copy a JavaScript file, rename it to .ts, and you can expect it to work, right? So that's the contract. So it's also called as JavaScript that scales. Quite honestly, I don't know what that means. Just putting it there. It was in the official documentation, right? I don't know what is JavaScript that scales, right? So I'm assuming it's something fancy. Yeah? I didn't bother to educate myself on that part. So it was fancy enough to put it there. So it has a type system which is strictly optional. You don't have to use the type system to use TypeScript. TypeScript is not just about the type system. There's a lot more to TypeScript than the type system. So it's optionally typed. Okay. It of course transpiles to JavaScript. Everything these days transpiles to JavaScript because you still have Internet Explorer to support, for example. So you have to transpile it to ES5 or if you are brave enough, ES6. And if you are lucky enough to not support older versions of Internet Explorer, then you can safely transpile it to probably ES6 and assume that it would work in all the browsers that we know of. It's maintained by Microsoft with major collaboration from Google. Slight backstory. How many of you have heard of AtScript? Good. So when the Angular team was building Angular 2, should have been named something else, but still. So they were developing their own superset of JavaScript as well. It was called AtScript. And aptly named so because it was heavily decorator oriented or annotation oriented. And because if you have worked with Angular, you know how much Angular loves the decorators or annotations, right? And it also makes the code less verbose in those cases, those use cases, right? And it's a very good use case for that. So they were building AtScript, and then Microsoft was also developing TypeScript, which didn't have the annotation support, but everything else was quite similar. And so for once, both teams decided it's better to join forces and merge their features together to have one community rather than splitting two community, which is ever fighting among each other, right? Which is a very good decision, and so we have TypeScript with a strong community behind it. It has great editor and IDE support. So if you have used VS Code with TypeScript, you know what I'm talking about, and I'll show some of that today as well. So for the record, right, I hate transpiling my JavaScript. I'm used to doing my JavaScript and seeing the result immediately. When I say immediately, I mean I can save, I can see the result, right? I'm used to that. When it comes to transpiling, you don't get that anymore. You have to wait for your transpilation phase to complete. You have to wait few seconds before your change is apparent. So it's a bit annoying. It reduces your velocity and all those things. So I hate transpiling. So whenever possible, I try to avoid that. But if I have to do transpiling, I would rather do it with TypeScript than with something else, right? Why? And so why would I do it with TypeScript rather than say Babel plus something or like whatever else, right? Because not just TypeScript doesn't only provide type safety for you. So of course TypeScript provides you strong typing. It does great type inference. It also provides great IDE support, right? In IntelliJ, in VS Code, Atom, whatever. It provides great support, easier to refactor your code. I'll show some of the refactoring that you can do with TypeScript. Great linting and error identification. Features from the future. Nicely put, right? Features from the future. So it's like if you're using Babel for getting, say, newer features, say ES8 or ES9 or ES10, you could also do it with TypeScript, right? While having the benefits of having more language features as well. Why would you transpile your code just to have some future features where you can also have more language features, right? Because you're transpiling anyway. Why would it matter? Of course, one of the argument would be that if you're using non-JavaScript language features, it would be difficult for you to migrate. But come on, and in reality, you are not sure if some of those features will make it anyway, right? And you're still using it. So that's almost as good as using features from TypeScript. And if you look at the way how the JavaScript ecosystem is going, most of the features in TypeScript is being implemented in JavaScript anyway. So yeah, for me at least, it's not such a big deal. So when it comes to Angular and React, of course, TypeScript provides a better coding style which helps you to write more concise and less verbose code in both React and Angular. So let's get started with some samples of code. I would go here. So I already have TypeScript installed, so I'm not going to install it. So let's say tsc when init. So it is going to create a tsconfig file. You can see the tsconfig file here. Right, most of the options are commented out for our reference, but what is important is your target, right? ES5 by default, because we still have IE11. So let's say we don't care about IE11, so let's say ES6, right, as our target, so that it's easier for us to compare the generated code. And of course, the module system is common JS. You can also use ES next if you want to go with the ES module system. We are not going to do a lot of module stuff, so I don't care for that. Let's also enable this one, output directory, so that we can see our output files in a different folder and it doesn't overwrite our actual source files when we do JavaScript files. Right, so put in a different directory, and let me close this. So let's also, okay, I'm going to split this so that I have another one here. So let's start watching our TypeScript server in watch mode, so that it starts watching this folder, and so that whenever something changes, it's going to transpile it on the fly, right? So first let's see how you can use TypeScript with plain JavaScript. You don't have to use .ts files, or like you don't have to migrate all your code base to TypeScript to start using it. You can start using TypeScript in your existing JavaScript projects pretty easily by just installing TypeScript as a dependency, and then by having some commented annotations. Say, for example, let's look at this file, right? Is it good? Okay, yeah. So I'm going to on this. So put it like this. Yeah, it's good. So this one you can see is from my transpiled folder. It's called main.js. We won't be needing that for now because we are going to work with plain JavaScript for now. So I have this JavaScript file. I'm also going to, yeah. So we have a name, a small function which says hello, right? Do you think this is correct code? How many of you think this code is correct? Okay. Let me enable this. So this is how you enable type checking on an existing JavaScript file. So you just say // at ts check. So it starts type checking, and immediately you see there is something wrong with the code, right? And what is it? So it expected an argument, but you didn't pass any, right? Because your method needs an argument for it to work. So let's say 10. No, still doesn't work. Why? Because you are expecting a string and you're passing an int, right? You're passing a number, so it doesn't work. So now it does work. So if we do right, it works. So this is how you can start using TypeScript immediately just by adding TypeScript as a dependency on your project, and you can add type checking and the goodness of TypeScript to your existing project without having to migrate anything. You can start to slowly introduce this annotation as you need in your project, right? This is a great way. And now you may ask, okay, if I'm not migrating my project, how am I supposed to use type system if I want to, right? Because doing this doesn't mean you're going to get fancy TypeScript features. So this doesn't mean that you can write, say, write this. No, you can't. Because when it is .js, you still have to other by features supported by the JavaScript standard. But you can also use any new features from newer standards as well. That is fine. But you can't use TypeScript features. You only have to use JavaScript features. But you can use, say, ES8, ES9, or ES10 features. That's fine, because it's going to transpile the code as well, right? So this is still invalid, right? So you can still use the type system, which is quite nice because it supports the JS doc syntax for type system. So you can declare your types as JSDoc like comments, right? So here, if you hover, you can see that it is identified as inferred as string because you have specified @type string in a JSDoc comment. Similarly, here you have specified a JSDoc param comment, and here, if you on your method, you can see it inferred the type. So this is how you can provide typings for your existing JavaScript files using TypeScript. So this is great for your existing project, right? So yeah, you can also do it in slightly different way. So if you want to do it for the end, if you don't like to add this annotation in each of the files, what you can do is you can enable this. Allo.js means it TypeScript will transpile your JavaScript as well. And you can enable check.js, which means it will start checking JavaScript files also for type errors and type safety. So you can enable these, and then in your files which you don't want to be type checked, you can use the no check flag as well. So you can mix and match it. You can choose whichever works for you, right? So let's look at some language features. So basic types, yeah, of course. So it has basic Boolean number string array types. You have boxed types with the starting with the capital letters, and you have primitives with the small letters. Always use the primitives for these types. Never use the, especially for Boolean number and string, never use the boxed type, because boxed types in JavaScript are notorious. Don't use it. They don't unbox well. So use the primitives. For array, though, you can use the primitive, square bracket syntax, or sometimes you can use the box type as well. It's okay, only in some special cases. But try to use the box syntax as much as possible, right? So these are the basic types, and there are some special types. Any, if you are used TypeScript, you are quite familiar with any, I would assume. How many of you use any a lot? People who are using TypeScript. I also do that sometimes. Sometimes you have to use any. There are valid use cases where you have to use any, right? Then you also have object, which is a more limited version of any. It is only applicable to object literals, because any is applicable to anything, but object is applicable to only object literals, which is good if you want to type a object which you don't know the type of. Of course, you can define tuple, which is nothing but array in the actual JavaScript, but in TypeScript you can define a type, a tuple type. So unlike in Scala, where I think you have up to 24, you can go up to even 100 if you want. So you also have a void type, which is normally useful when you have methods. You can assign the return type as void. Similarly, you have undefined null and null, which are only useful in certain cases, especially when you are using strict null type checking. Sometimes you might have to specify that a particular field is a string and also nullable by specifying string or null, right? So it's also useful. Similarly, you have never, which is used for functions with unreachable code. So especially for functions which are going to throw an error, you can return, if you know that this function is always going to throw an error, you can specify the output as never, right? That means it ensures that you are never going to use that function in a context where you are not expecting an error, so which is useful as well. You also have enum types. It's quite nice. You can have basic enums similar to almost Java-ish kind of syntax. You have basic enums. You can have enum with a number value, numeric value. By default, enums have numeric values, so they will be in running sequence. You can override that by specifying your own value if you want, and you can also have enums with text values, right? String values. And you can assign the type for variables using the enum. Interfaces. So let's look at let's close this file. Let's go to this one. This is going to be compiled to this file, right? Because this is from my transpile folder, you can see, which is this one. So let's see interface, person interface. So this is an interface, and you can see there's nothing here, right? Because this doesn't mean anything in JavaScript. This is only for TypeScript's reference. So let's go ahead and implement this interface with an object. So let's say I have this object, which is of type person, and I have values and stuff. So now when I save, okay, for some reason it doesn't let me open it up again, probably. What did I miss? Yes, I didn't start after specifying my output folder, right? So sorry. Yeah, let's close this. Yeah, sorry about that. Yeah, so now I have an object, and you can see the equivalent JavaScript, the transpiled ES6 JavaScript. So you only have the object, right? Because the type doesn't matter there, and there's no much difference here, right? Because it's an ES6 syntax. So this is how you will define an interface. But this helps you. Say, for example, if I am going to add foo here, it's going to complain because it doesn't identify that, right? So that's nice, right? And let's see function interfaces. So what you can also do is define interfaces for functions. You can also define interfaces for function signatures and use that. Say, for example, here we are defining interface for a method which adds 2 numbers, right? So this is the method signature, and this is the return type. And you can assign that to functions, and then when you say, for example, call this function and provide, it's going to comply, right? So if I say 2, 2, it's fine. So you can also define types of functions as interfaces and reuse them. Instead of defining types of functions for each function separately, you can define as types and reuse them as well. That's a good way to modularize your code as well. So let's look at some more complex stuff. So these are basic language features. I'm not going to spend a lot of time on basic features because I want to show you what really you can, the powerful things that you can do with TypeScript later on. So I'm going to go faster on these. So of course you can extend interfaces. You can create a new interface from an existing interface. You can also create a new interface from an existing class, because TypeScript kind of, say, let's take this for example. We want this. Let's, okay, person class implementation. Let's say this class. So this is a class that implements a person interface. So you can, that means when you have this, and if you don't specify anything, it's going to complain that you didn't implement whatever you declared as your interface. So you have to implement everything, right? And then you can go on and create another interface, say foo, which extends u, which is this, right? So what TypeScript does is, it doesn't care about the implementation. It only takes the types from that particular class and uses that to create an interface. So you can extend both interfaces and classes to create new interfaces. And also you can implement classes or interfaces to create new classes as well. So both are possible in TypeScript, right? Class modifiers. So this is another good language feature provided by TypeScript. Of course, the latest version of JavaScript, there is a proposal to have private variables with a hash in the beginning, but TypeScript has even better syntax for that. It has proper private protected public modifiers. So within classes, you can specify class attributes as private, public, or protected. And also you have a special read-only property. Let's see how these behave. So we have this class with some modifiers, right? And why is it not compiling on the run? Okay. Okay, 1 second. Something is wrong here. My transpilation doesn't seem to work. It's weird. Okay, something went wrong there. Okay, so okay, let's close this. Okay, so this gets transpiled to basically a simple ES6 class, right? You don't see the private protected variables there because it's a TypeScript feature. But you can also do read-only feature, say foo boolean. Okay, we don't have to specify that because TypeScript can infer types, right? So if you just specify the value directly, TypeScript knows what type it is. You don't have to specify types when providing value. So this is also not required actually. It can infer that it is a string. It's smart enough to do that. So in this case, when you do let person, so greeters equal to new greeter. Same here. You don't have to specify the type. It can infer the type, but you have to provide the message here. So let's say world. Now, if you try to modify foo, it won't let you because it's a read-only property. It will say that you cannot modify this. This is extremely useful if you're working with state management libraries like Redux or something like that, where state modifications or mutating your state could lead to unexpected behavior. So in those cases, if you use read-only types with those state declarations, you can be sure that you don't accidentally mutate your state in your code. So that's a great use for read-only. I'll also show that a little bit later in a more advanced example. You can also have the next one is static properties. Of course, with ES, the latest JavaScript, you can do static methods, but you can't do static properties. Whereas in TypeScript, you can do static properties. So you can declare static properties which can be used like this. Greeter dot, sorry, what was it, bar? Yeah, you can do this. So static properties are also supported. So you can also declare abstract classes. That means when you have an abstract class, you can't use that class directly. You have to implement it. So if I mark this as abstract, and if you can't do anything because it's an abstract class. So you have to implement that class with another, or sorry, you have to extend this to create another class, and you can only use those. So that's also supported. Function overloading. How many of you know that there is function overloading in TypeScript? Good. So it's quite a weird syntax. That's why most of you, even you might have seen this, but you might not have realized that this is function overloading. So let's right? So this is addition method, add method, which is overloaded. How can you say that this is overloaded? Because I have a syntax which says x can be any, y can be any, which returns any. No, this is not overloading. This is how you overload. By specifying these two additional signature on just top of your actual function, you specify the overloading. This doesn't mean that this function has 3 signatures. This means this function has only 2 signatures, which are specified by these 2. When you overload a function, it is mandatory to have a signature like this, like any signature, right? Only then you can actually do the overloaded signatures. And if you try to do something else like true, for example, it won't work. Say or even let's say this, it won't work because it cannot take that particular type. It can be only a number, for example. So you only have these 2 types declared for this, right? So this is function overloading. And also, this doesn't mean that you have to strictly have the same set of number of parameters. You can, of course, have this syntax as well. That means this will complain that it is not, this particular signature is not compatible with the implementation. Because when you have a signature, you have to make sure you have an implementation matching that. So TypeScript scans the function and complains if you don't. So that means you have to do a proper type check. You have to see that there is only one argument and do a specific return for that. Then this will be accepted. So that's function overloading for you. Generics. So if you're coming from a Java background, you know how useful and how handy generics are, right? They are one of the most useful feature in Java, right? Which makes you write type safe as well as less verbose code and reusable code without having to duplicate a lot, right? So TypeScript also gives you generic. So let's say this is our generic class, and you can see from the compiled one, it compiles down to again a simple, ES6 class. Nothing fancy there on the compile code. But here we specify a generic for this class, and we use that as the type throughout our implementation of a constructor or private variables or whatever. So that means I can have a greeter with a string argument as well as number argument. Both are valid. So this is simple generics, almost similar as in Java. You can also have the extends usage. You can have generic extends feature as well, same as in Java. So say for example, so we have this method, right? So let's say I don't have an extend here. So now if I try to use r.length, it will complain that it doesn't know what length is. It's logical, right? Because from just specifying this, TypeScript doesn't know what a length is. If I provide something like it still doesn't. It still cannot infer because you only say generic. It can be anything, right? So it confuses the types in TypeScript. So this is where you use the extends. So now it knows that this particular type is extending this, so it has this particular argument. So this is how you can do the extends to make your type system more safer and more granular, right? So decorators. So decorators or annotations. This is the feature that TypeScript took from AtScript, right? So you can have decorators on methods, you can have it on classes, properties, parameters, or accessors. These are the multiple types of decorators that are supported. Let's see an example. Let's see a method decorator, right? So now when we have a simple class foo, have a method, and I specify @log as a decorator for this, right? But it complains. It says you cannot use this because it's an experimental feature. That means in your TypeScript tsconfig file, you have to go and enable this. So I have to put a comma here. You have to enable this for this to work, right? Now it can identify the decorator syntax. And in the transpile code, you will see a lot of generated code with some reflection going on there. That's how the decorators work. So if you look at the decorator method itself, it's a quite simple method. It's a small function which takes a few arguments. It takes a target, which is your context. In this case, the context is this class itself. So that's the context here. And you have a key, and in this case, key will be a foo, and you have a descriptor. Descriptor is a reflection metadata for the property that you are working on, right? And you can say do something in that log method, and say if I run node transpiled main.js, you can see you have two log statements. So hello there was from the foo method itself. So I am calling foo method here. So of course it printed hello there, but you can also see key was called, which was from the decorator. So this way you can decorate your existing functions or like classes with additional behavior. So let's see a more complex example. So this is the same thing here. Nothing has changed here. But in the decorator method, what you can see is from the descriptor, we are getting the value. So in this case, value is a function. So we are assigning that to a temporary variable. And then we are overriding value with a new function, which adds some additional behavior here. It is still doing a log, but with the arguments of the function, right? This is the arguments keyword from JavaScript, right? And then you're returning the original function, right? So this is almost like a AOP syntax that you might be familiar from Spring and kind of thing, right? So this is almost like AOP. So that means you can do AOP kind of things in TypeScript as well. So if you run this, you will see that it prints that, and also it executes the original function because we are applying the original function at the end as well. So this way you can manipulate existing functions with additional behavior without having to touch the function code and stuff like that, like generic stuff overall, like logging, initialization of stuff, you know. Let's see how a class decorator looks like. So this is still the same log one for the method, but then we also added this init, right, method. So let's see here. So the class, we have two variables, and there is no string. So if I execute this, what do you expect to happen? You might expect that it's going to print empty, right? But no, it has printed. This is my wife's name, by the way. It has printed some value from this, whereas you have not declared anything. That's because of this particular decorator. If you look at the decorator code for init, right, it actually returns an extension of the constructor where you are overriding the properties with some values. So you are initializing those values within this decorator. And if you look at the syntax, it has a weird type. It's of course a generic, but just providing a generic TypeScript, say if I don't have this, TypeScript will not know what this constructor is. So you have to have this extends with this syntax for a constructor. So a constructor syntax is new with arguments which returns something, right? So it's a syntax, then you can use that generic here and you can extend this. So this is how class decorators work. Yeah, so mixin. So TypeScript also has a concept of mixin. So it's not technically a language feature, it's just that something TypeScript allows you to do, kind of. So you can have, say, methods. Let's see a concrete example, kind of. So let's say here we have a runner class, right? It has some methods and attributes. Swimmer, right? Then say you have a person which has to have both. This is so mixin is similar to traits in Scala. It's not exactly the same, but it's quite similar to traits. So you can have multiple traits or classes which can be implemented on another class. So when you implement this, normally if you implement something, you have to provide the implementation, right? But here, actually, we are providing dummy implementations. So it's a quite weird way of doing mixins. So because it's not first-class support for mixins, it's just something that is tolerated. So you have to do a dummy implementation so that TypeScript is happy about the extension. Then you can use this method to apply mixin. You would expect this method to be available from TypeScript, but no, it's technically actually a small piece of code that you have to put in yourself. So TypeScript provides this in the samples. That means you have to put it somewhere in your library or runtime. Then you can use that to technically just iterate over a set of classes and copy over all the prototype properties from that class into the base class. That's what you're doing. So because JavaScript is prototype based, so you can copy over something from one prototype to another dynamically. It just works in JavaScript. So you can make use of that to do mixins kind of things. So it's like a weird way of doing mixins, right? So TypeScript also has a very good type inference, as I showed you. So it can, most of the times it can infer your type. So a general way of when you're working with TypeScript, don't start assigning types, right? See if your compiler complains. Only when it complains, assign types. Don't start with any, of course. Start with nothing. Start with something like, say, for example, right? Oops. Start something like this, and if it doesn't complain, that means it is inferring it properly. And you can trust TypeScript infer it properly. So just leave at it. Only define a type when it complains. And TypeScript can infer from methods. It can infer from primitives, most of the complex types. So when it infers, let it do that, and don't bother with providing types. So that's it's very good to have type inference. So advanced types. So you can have literal types, which is very good. Because you can say a particular type can only accept actually certain values. So you are not saying that type color is a string. You are saying type color has to be specifically these values. That means when you assign this as a type to something, say for example, if I say it doesn't accept that, right? It doesn't accept that. But if when you say, it does. So it's quite useful to have that. You can do that for strings and numbers. So this is now where it gets interesting. So you can have intersection and union types. So sometimes you have a requirement where you have two types and you need a third type, which is an intersection of that, which is like, or intersection or like just ANDed, right? So here you can have a runner and a swimmer, and you can say a type person is runner and swimmer, so it has to be both, right? Similarly, you can also have union types or an OR type, where you can say person has to be either runner or swimmer, but not both, right? So let's see an example. So we have a runner with some attributes, a swimmer with some attributes, and we have here, this is the intersection type. So that means you can have a person which implements both. Everything works, right? So now if I change this to union, this part is still fine. You can implement both in your classes, but you can't directly like use both. It'll get confused. It will complain that it doesn't exist because it has to be either this or that, right? It can't be both at the same time. That's how OR works, right? So this is where the next feature comes in, type guards. So let's see how to do this with type guards. So let me remove this, which doesn't work. So now I have this small check, right? It checks if this is a person is swimmer. And if it is swimmer, I call swim. If it is runner, I call run, right? So this works. How does it work? Because we have type guards. So if you are writing union types, a rule of thumb should be, if you are writing a union type, always write a type guard for it. Never write a union type without a type guard. You will always end up in trouble. You will be spending endless time figuring out why a particular thing fails, why there is a type failure. It is always because of union types not having a type guard. So if you have a union type, have a type guard. So this type guard is nothing but a small method which takes both the arguments. Again, this is like a union here, and then it goes on to say output is always one particular type. So you are casting the output to be always of one particular type. So this is the type guarding. So this is where you're guarding the type, right? And within in your return, you can always check for a specific property of that particular type to determine if that type, if this is of that type or not. Then you always have to cast it as well. This is how we cast in TypeScript. So here we are casting for swimmer and see if its swim exists. Here same for run. So when you use this inside the type guards, it instantaneously works. It just identifies the correct type and works. So you can always make sure your logic for a particular type is properly implemented. Map types. So this is the most interesting feature of TypeScript, which actually makes using TypeScript easier, less verbose, and gives you, say for example, more reduced code base in a type kind of perspective. How many of you have used map types? Okay, only one person. That's good for me. Okay. Okay, I also need person. Right, so I have a person interface. So let's say I want to have person read-only interface, where I want to say, so I want to do this, and then this is often you have these kind of needs, right? You have a type and you want a type which is same as that but with slight modifications, right? You often want this, but then you can't keep replicating that your type, right? So what we can do is, instead of doing this, these are built-in. So I can say read-only person is a built-in read-only type of person. So this gives me a read-only person. So this is mapping types, right? Similarly, say for example, I want a partial type where everything is optional. So I can use partial. I can get this where all my types are optional. So how does the implementation look like? So the implementation looks like something like this. So you can also write your own. Say for example, I can do my own as well, right? Say I can say read-only nullable. Read-only and nullable person, right? And let's say, so the syntax is you use something like this, iterator kind of syntax, so foreign kind of thing with a key of which provides that mapping feature, right? So here I say the generic that you pass has to be mapped for every field of the generic. You are iterating for every key. You will map the key to this value, right? So here I can say read only, and also I can say this is nullable. For the value, I can also add a union of null. So when the output will always be my actual thing with what I mapped, right? So this is almost like doing a for each, map, dot map in JavaScript kind of thing, but with a different syntax. So this is how you can map. So let's see another example. What was my another example? So let's see this example, right? So I have an object. Say, for example, this is a state from a Redux function, right? Redux state. So I have a declaration of the state. Now I want to type this. So what should I do? Should I create an interface defining everything? No, that's too boring. I'm not going to do that. So what I can do is I can just say my type is read-only type of this object, right? So it actually infers the type pretty well and provides the type declaration for that, which I can use throughout my code. Now for my reducer methods, I can use this type, right? So this is quite handy. So what more can you do from this? So I only have 4 minutes, so I'm going to go really fast, probably. So say, for example, I have a method, say this particular method, get session. I have a map state to props where I'm mapping a few properties and stuff, giving an output. I also have a map dispatch to props where I'm mapping the session variable. And here I declare two types. So state props. So this is for a React component. I need to provide a property type which extends state props and dispatch props. This is quite common when using React with Redux, right? You always have, your property is always made of your state props and your dispatch props, right? So my state props are nothing but return type. It's another map function. Return type of my map to state props. So it takes the out type of this particular method and maps the return type. So here I actually get the type of my return of that particular function. Whereas my dispatch props is just a type of my particular object, because it's a simple object. So it gives me the type of my actual function, which is declared here. The function declared here. So it gives me that. It's quite handy, right? Then I can use that to compose a nice type, right? So this makes my React code really concise. You don't have all that nasty type declarations everywhere or prop types everywhere. So like, you are actually using an existing code to generate the types using type inference and using that as your type to ensure type safety, which works perfectly well. So I'll mention an example. So that's all about, was this my third example? Yeah, I only had 3 examples. So you can also do type aliases using the type keyword, which you already saw. So type keywords are almost identical to interface. The only difference being type keywords can also alias primitive types. So you can create new types from existing types. You can create new types from complex types, an example, stuff like that, type aliasing. You also have index types where you can specify, you can use the key of feature again to provide a very complex syntaxes. I don't have enough time to go into this, but you can. This is the same example from the TypeScript documentation. Please refer to that. I'm sorry that I don't have the time to go into this. So if you're kickstarting Angular, Vue, or React with TypeScript, the best way to do is to start with the CLIs, because all the say Angular CLI support does with TypeScript. So start with that. For Create React app, it supports TypeScript, and also you have a TypeScript starter script to generate a project with that. Same for Vue CLI 3, it also supports TypeScript. So you can start with that to get a proper TypeScript configuration for your project. And if you want even more than that, for React, Angular, or Java, with TypeScript, you can always use JHipster. You can obligatory because I'm the co-lead. So You can use not kidding, you can use JHipster to generate the project, saying we have made use of all these features quite well, especially in the React implementation. We have used map types extensively. You can generate a project using JHipster for React, and you can see the code. You can see how less verbose it is compared to writing it in plain JavaScript or with, say, prop types instead of TypeScript. You can see how less verbose and how concise and beautiful the code is. So check that out. And of course, the best editor to use for TypeScript, my recommendation would be VS Code. You can't beat VS Code when it comes to TypeScript. IntelliJ is close enough with the TypeScript plugin, but it is only available in Ultimate. But still, it can't beat VS Code, because VS Code is natively written in TypeScript. That means it has the best support. You can do stuff like, say, for example, quickly, let me show person interface and say person object. So one of the things that you can do is, which is not possible in JavaScript, right? You can refactor, say, some methods and stuff normally if your IDE supports that, but you can't do property renaming, right? Say, for example, you can do this, and you can see it renamed in my implementations as well. So when you have a properly typed project with TypeScript, you can actually do real refactoring of your classes and all those things. So that's it, and these are my books. I don't have time for that. Thank you. Yeah, I hope you learned something from this.